Hey kids, welcome to lesson 2.7, string methods. A string holds a character in a sequence. Each character is at a position or index which starts at 0 as shown below. Kids, if you remember from my AP CSP class, we always start counting from 0. Just like the number systems 0 through 9, so does our indexes start at 0. An index is a number associated with a position in a string. The length of a string is the number of characters in it, including any spaces or special characters. The string below has 14. If you look right here, this is going to be our reference for everything moving forward. You can see it has 13 numbers, but we start at 0. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. That makes 14 right there. Note the first character in a string is at the index 0 and the last character is at length -1. You'll remember that code also, kids, from AP CSP. For the AP CSA exam, you only need to know how to use the following string methods. All of the string method descriptions are included in the AP CSA Java Quick Reference Sheet. I'll pop it up right here. You get this during your exam, so you don't have to memorize these. If you look, we have integer length. Method returns the number of characters in the string, including spaces and special characters like punctuation. String substring, that is integer from to integer to. Method returns a new string with the characters in the current string, starting with the character at the from index and ending at the character before the to index, if the to index is specified, and if not specified, it will continue the rest of the string. We'll understand this here a little better once we see that, kids. It's not as complicated as it sounds. Index of, that's string. Method searches for the string in the current string and returns the index at the beginning of the string in the current string, or -1 if it isn't found. Compared to string other, returns a negative value if the current string is less than the other string alphabetically, 0 if they have the same characters in the same order, and a positive value if the current string is greater than the other string alphabetically. Again, kids, this will all make more sense once we get to the examples. We also have Boolean Equations. This returns true when the characters in the current string are the same as the ones in the other string. This method is inherited from the object class, but is overridden, which means that the string class has its own version of that method. Don't worry, kids, if your head's spinning, we're going to go into some examples of all of these, so do not worry. Run the code below to see the output of the string method length, substring, and index of. I think we're going to learn here, little kids. The length method returns a number of characters in the string, not the last index, which is length -1. The string substring from to method returns the substring from index up to, but not including the to index. The method string index of substring searches for the substring in the string and returns the index where it finds the substring in string, or -1 if there is none. Oh. Again, kids, your heads are probably totally spinning. Let's go ahead and run this code and talk about it. Probably makes a lot more sense. If you see here, let's take a look at the code now. We have message 1 and message 2. Message 1 is, this is a test. Message 2, hello class. Keep that in mind, that's very important. The first one is a length here, so we have message.1 length. If we count this up, it is 0, remember, start at 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. We started at 0, so that's 14 characters. Just as a note, kids, remember, we count 0 to 13, but in normal human speech, we start at 1. So there's some difference. Hello class. System.out.print message 2 length start at 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Well, we add 1 because we started at 0. Well, that's 11. Now We're going to go down to substrings here. This is going to print out message substring 0 to 3. Well, if you look, if we go to message 1, 0 up to 3 is THI, and you'll notice there it is. So when we have two coordinates in there, it starts at whatever that number is and goes to the index before that. System print out substring 2, 3, so we're still in 1. This one, if we go 0, 1, 2, remember, we're discounting that last one, so that's just the letter I. There you go, we got I. Down here, we have our systemout.println. What is the message 1 index of is? This is matching to the word this, just printing that out. So if we do is, this right here, 0, 1, 2. So remember, this is the returns a substring from the index, but not including the 2 index. So that just goes all the way up to there. We now have our message 1 index of hello. Well, kids, there's no hello in there. So if you look, if it returns an index where it finds a substring is not there, it's going to give us a -1. There's our -1. That's because it's not there. System.out.print message to index of hello. Well, in this one, hello and hello are right there. So they start. That means it is 0. So remember on this one, it went up into including it. Well, that starts right there. So no more to go. If you look, we have the last two. The last two out here, we have message to lowercase. Looks like it takes everything to a lowercase and a uppercase, and everything goes to uppercase. These kids are going to be pretty important. We're going to use them quite a bit here. So if you don't understand them, play around with them. Change the numbers around, test yourself, and see what's going on. It's pretty helpful, kids. Again, kids, this is going to be pretty important. Please take the time to understand it. If you don't, add some different numbers here. Change the words around. It's a lot more helpful when you start putting your own stuff into there. I promise you one thing, you'll see much more of this. We just have a note here. Remember that substring from 2 does not include the character at the 2 index. So we don't include the end one. Just remember that. So we start counting, and we go all the way up to the 2 index. To return a single character at the index, I use string substring index plus 1. So you'll see that there. So this is just a note. If you want to get the whole thing, you have to add this line of code instead of 2. What is the value of POS after the following code executes? We have A, B, C, C, B, A, and we want the index of B. So we want to know what that number is. Well, that's 0, 1. So the answer is going to be 1. What is the value of the len after the following code executes? We have baby, and we want the length of s.1. Well, that's baby. That's 0, 1, 2, 3. Remember, we count as actual characters, though, kids, so it is going to be 4. What is the value of S2 after the following code executes? We have our string baby. We have our substring here. It is going from 0 to 3. Remember, we go from that position up into that. So 0, 1, 2, and we stop there because we don't include the third one. We have bab, should be number D, and that's right. What is the value of S2 after the following code executes? We have baby. We have S1 substring 2. Remember, this goes to the position of and returns whatever is after that. We're going to go to position 2, so we're going to count that as 0. That is 1. So 2 over is going to be by. So the answer is going to be by. So this returns substring with just a number, remember, goes over to whatever that is, and then returns the remaining. 272, compare to and equals. We can compare primitive types like int and double using operators like equal, greater than, or less than, which we'll learn about in the next unit. However, with referent types like strings, you must use the method equals and compare to, not equal or greater than or less than. This is just saying we have to use compare to, not equal, greater than, or less than. So that's just a big hint right there what this is going to be. The method compare to compares two string characters by character. If they are equal, it returns a 0. If the first string is alphabetically ordered before the second string, which is the argument of compare to, it returns a negative number. We'll see this in a second, kids. So if it's out of order alphabetically, it's going to be a negative number. But if the first string is alphabetically ordered after the second string, it returns a positive number. The actual number that it returns does not matter, but it is the distance from the first letter that is different. Just another note, the actual number that it returns does not matter, but it is the distance in the first letter that is different. Example, A is 7 letters away from H. So just keep that in mind. Remember, we always drop the last index. The equal method compares the two string characters by character and returns a true or false. Both compare to and equal are case sensitive. There are case sensitive versions of these methods. Compare to ignore case and equal ignore case, which are not on the AP exam. Run the example below to see the output from compare to and equals. Since hello would be alphabetically ordered after and, compare to returns a positive number. Since hello would be alphabetically ordered after zoo, compare to returns a negative number. Notice that equal is case sensitive. Let's run this code here. Let's go through and actually understand this now. So the message compared to hello, we're comparing these two. And when we compare hello, well, those are the same things, right? That means they're equal. Kids, we're going to get a 0. Now, we are comparing and all we're worried about is the first letters here. So if you remember, A is 7 letters away from H. I'll bring up an alphabet here. And you can see when we go to count it, A, B, C, D, E, F, G, that's 7 letters. Remember, we don't go to the last one. That's a positive because remember, H compared to A is after it. So that's a positive number. It goes A, because that's where it's getting compared to, positive number. Let's try the same thing here. System.outPrint message compared to zoo. So now we're comparing Z to H. And you will see that now hello compared to zoo, well, that's not grammatically right. It should be the other way around, so it's a negative number. And if we count from H to Z, we're going to see it's negative 18. Down here, we have message equals hello. You see these are both equal here, and they are case sensitive because we're using the equals. It has to be exact, so that's going to give me a true. Since this is lowercase and this is uppercase, it is not equal, so that is a false. There are a lot of other methods in the string class. You can look through the Java documentation for the string class online. You don't have to know these for the exam, but you can use them if you want on the exam. An Application Program Interface, API, is a library of pre-written classes that simplify complex programming tasks for us. These classes are grouped together in a package like java.lang, and we can import these packages or individual classes into our program to make use of them. For instance, we just discussed a string library built into the default Java lang package. It takes care of all the detailed work of manipulating strings for us. There are many other useful library packages as well, both in the Java Lang package and in other packages. Documentation for APIs in the library are essential to understanding how to use these classes. We have a note here. This is just saying strings are immutable, which means they cannot change. Anything you do to modify a string, like creating a substring or appending the string, returns a new string. That means whatever this is, we can't change it. We have to make it into something else, maybe an instance, for example, in order to get there. That means if we have all uppercase, well, we have to create a new string to make it lowercase. And we'll see an example here in a minute of that. Drag the definition from left and drop it on the correct concept on the right. Click the Check Me button to see if you're correct. We have some definitions here. Looks like we have doesn't change, a new string that is part of another string with 0 to all characters copied from the original string, the number of characters in a string, the position of a character in a string. Well, starting up here, our note, immutable, doesn't change. That's a pretty easy one for us kids. We can throw that on there. A new string that is part of another string with 0 to all characters copied from the original string. Well, if it's new, it's a sub. So that's going to be a substring right there. The number of characters in a string, well, that's going to be the length. And then the position of the characters in a string, well, that's their index. We have some more vocabulary words here. Returns a number to indicate if one string is less than, equal to, or greater than another. Return the position of one string to another, or -1. Returns a string representing the object that is passed to this method. Returns true if characters in two strings are the same. Let's go through this. Returns a number to indicate, well, if it's less than or greater to, remember that's our compare one, so I think that one goes there. Returns the position of -1. Remember that's the index of kids, everything up into that. Returns a string representing the object that is passed on to the method. That's our toString. And returns true if the characters in two strings are the same. Well, that is equals, kids. Hey, good job. We have some multiple choice here. What is the value of S2 after the following code executes? We have a new string, hi there. S1 is an index of E. And this one, it's saying index of E, and then we're creating a new substring, and we want 0 position. And what this one is asking is, where is the first occurrence of both of these words here? And since there's an E, we're discounting it after that instance. So we're looking at anything after the E in the first positions. And if you look, we have HI and then TH, that discounts that. We have an E there and an E there, so that's not going to do it. So the only one that fulfills this is A. What is the value of S1 after the following code executes? We have S1 high, then S2 is S1 substring 0, 1, which is high, and then S3 is S2 lowercase. Now, kids, this is a tricky one. What is the value of S1 after the following code executes? Remember, strings never change. We're just making more of them. The original answer is the answer A. What is the value of S3 after the following code executes? We have our string 1 high. String 1 substring is going to be 0, 1. So S2 is just going to be 0, because remember, we dropped the last one, and then we're going to make that lowercase. That means the answer should be H. What is the value of the answer after the following code executes? We have high by, and we're comparing H to B. So does H come after B? Well, yeah, A, B, C, D, E, F, G, H. So it does. It means we're going to end up with a positive number. 0 would be equal, and then the other one would be ungrammatically correct. Good job, kids. Common mistakes with strings. The following code shows some common mistakes with strings. We're going to do some fixing here. Let's go ahead and run this code and see what happens. What's it asking here? Well, if you look through, we're going to compare them. We're going to print out the first letter in string 1, which is hello, and then we have substring 1 at 1. And if you look down here, the first letter in hello is H. But doesn't look like our substring is right here, because we have to return H and we're not getting that. And what is H going to be at? It's not going to be at 1. That would be, well, that's not anything. Remember, we dropped the last letter, so it's actually going to be 0, 1. And I bet you that's going to get us there. The last character in hello, well, it's printing out the last character in hello is at 8. Let's count here. 0, 1, 2, 3, 4, 5. The last character, not the last letter, kids. The last character is at 5. So we should have to put it to 5. Now we have to worry about this last part here. It has string 1 to lowercase. Well, remember, kids, strings are immutable. That means they don't change. We have to create another one. So doing this is going to give us an error all the time. What do we want to do then? Well, we want to create a new string, right? So we're going to create a new string, and we'll just simply call this 2. And that's going to be equal to what? Well, that's going to be equal to our string 1 to lowercase. So we're just creating a new string, because remember, these are immutable. We can't do anything about that. So we have to create a new one. Now that we did that, we also have to print out the one we just created. I think now our code's going to work. There you go, kids. Everything there. So don't forget to do all the parts of it. Here's a list of common mistakes made with strings here. Thinking about substrings include the characters at the last index when they don't. Remember that. That's a big one, kids. Thinking that strings can change when they can't. They're immutable. You can't change the strings. Kids, much like me, you can't change the strings. Trying to access part of a string that is not between index 0 and the length -1. This will throw an out-of-bounds exception. Trying to call a method of index of in a string reference that is null. You'll get a null pointer exception. Remember, if you have a placeholder, can't call the placeholder. Using equal to test if two strings are equal. Remember, in strings, we have to use the compare to method. Usually you only want to know if they have the same characters in the same order. In that case, you want to use equals to or compare instead. Treating upper and lowercase characters is the same in Java. If S1 is high with an uppercase and S2 is high with lowercase, then S1 equals S2 is going to be false. So remember, they're different, kids. Kids, can you speak Pig Latin? In Pig Latin, you take the first letter and put it at the end of the word and add the letters A to the end. For example, pig becomes igpay. Create a program that takes the word and transforms it into Pig Latin using a string method. You may need the word's length. A substring does not include the first letter, and a substring is just the first letter. You can get the ith letter of a string using the substring I plus 1. For example, the letter at index 3 would be a substring 3, 4. Kids, I'm going to have you do this in Replit, but we're going to do this here in Runestone. Well, kids, how are we going to write it here? First, we have to come up with a word. Well, you know a word I'm going to pick, kids. Roads. Next, we're going to go to our variable here, Pig Latin, and we're going to start constructing it. And how are we going to construct it? Well, we're using word, right? And we're going to use a substring. And if we remember, we want everything after the first letter. So we're going to print everything after 1 over. So that should be HODES. Well, you remember, we also have to put our first letter in there too, right, kids? So that's going to be word substring. And I want the letter R, and to get the letter R, that's going to be a 0, 1. And then we need the word A at the end of it. We're printing it out literally, so we need quotation marks and a right. And of course, a semicolon. Then we're going to print out our word, roads, in Pig Latin is, and it should say, Hodes are A. I think that's right, kids. You can slow that down and make fun of me if you want. Well, let's save and run and see what happens. Roads in Pig Latin. So R1 prints out everything after the first letter. So that's HODES. 0, 1 is the letter R. And then AY is the literal afterwards. And that's how we did it. So that's how you create some Pig Latin. You're going to be doing a little more than that though, kids. But that's a separate video. Here's our summary, kids. Index, a number that represents the position of a character in a string. The first character in a string is at index 0. Please remember it is super important. Length, the number of characters in a string. Substring, a new string that contains a copy of a part of the original string. A string object has the index value from 0 to length minus 1. Attempting to access outside this range will result in an index out of bounds exception. String objects are immutable, meaning that string methods do not change the string object. Any method that seems to change a string actually creates a new string entirely. The following string methods and constructors, including what they do and when they are used, are part of the APCSA Java Quick Reference Sheet that you can use during the exam. We have a string, constructs a new string object that represents the same sequence of characters as string. We did that one today, kids. Returns a number of characters in a string object. We did that one too. The substring from 2 returns a substring beginning at index from and ending at index to -1. We also did that one today, kids. String subtract in from returns substring from length. Index of searches from the string in the current string and returns the index of the first occurrence of string, returns -1 if not found. We played with that one too as well, kids. We have Boolean equals, returns true if this, the object called, is equal to the other, returns false otherwise. You guessed it, kids, we did that one too. And compared to returns a value of less than 1 if it is less than the other, returns 0 if it is equal to, and returns a value greater if it is greater to. And then, kids, remember, string substring, index, index plus 1, returns a single character at the index in the index string. Kids, I'm not going to do anything on this game here, but I highly recommend doing a little practice and playing this game. It is pretty awesome. Big shout out to Shandon Sakar for creating this. It's a pretty awesome game. Again, great practice for the AP exam. And that's it for this video, kids. As always, if you had any questions, please let me know. Otherwise, I'll see you on the next video. See you later, kids. Bye, bye, bye.